Good morning, everyone. Today we are going to address population ecology. Now, before we address the ecological aspect of things, let's take a look at population. So, what is a population? Basically, a population is a group of individuals belonging to the same species and that live in a given geographical area. So, what is population ecology? Well, population ecology is going to study the interaction between individuals that belong to the same species and living in a given geographical area. So, this is what we call intra-specific interactions or intra-specific relationship. So, in population ecology, well, we are going to take a look at a certain number of aspects that we are going to address. But first of all, let's see why population ecology is important. Well, when we consider the human population, for instance, well, we said that the human population right now, it's about 7 billion individuals. Now, that population is growing at a certain pace. How can we come with a prediction as of how the human population is going to grow? Well, we have to study the pattern of growth of human population. The same thing is true for animals, plants. For instance, when you consider in Tuscarawas County in Ohio, you have a fairly high amount of deer population. So it's very important to know that in Tuscarawas County, you have a relatively high population of deer that allows the government to set when it's okay to hunt deers and when it's okay to stop hunting deers. Likewise, you also have some species that are threatened of extinction. So how do we know that the species are threatened of extinction? Well, it's because basically by studying the population of that particular species in a given geographical area, we are going to notice that where we count less and less individual of that species. So there are several reasons why it is important to study population ecology. So I was talking earlier about intraspecific relationship, but I did not mention that these individuals are also going to have to interact with their environment. So in population ecology, we also look at what are the environmental factors, what we call abiotic factors that affect the growth of that population. Now, that said, what are some important aspects of population ecology? Well, we are going to take a look at the population size. Now, we're going to notice that the population size fluctuates as new individuals are born, as new individuals come in the group. So these are the immigrants. And as new individuals leave the group, these are immigrants. And also some individuals die within the group. Okay? So these different aspects, so the birth of new individual, immigration, emigration, and death, all of that is going to affect the fluctuation of a population, the size of the population, I'm sorry. Now, in population ecology, we estimate most of the time the population because it's not always obvious to have an exact count of the number of people. Let's take a look, for instance, at the human population in the United States. Well, in the United States, the human population is actually relatively well predictable. That said, in spite of all the technology that we have and all the programs that we have to count the number of individuals, new birth, people who die, immigration, we are still doing estimations. Okay, it's still estimations. We cannot really have an exact count of individuals, but we have good estimations. Okay, good estimates, I should say. So that said, we use population density to most of the time to determine actually the size of a population. Now, what is population density? Population density, it's going to be basically the number of individuals that are living in a given geographical area. Okay, so that population density, for instance, when we look at the population of rodent in a given geographical area, for some rodent, we're going to take a look at the number of burrows. Okay, by counting the number of burrows, we can estimate the density of population. We can estimate the size of the population. Okay, now another aspect that is important in population ecology is going to be the distribution of a population. Now, in some species, population individuals in a population likes to keep a certain distance among individuals. Some species are going to basically be organized according to a random pattern. Okay, so it doesn't matter if they are close together or if they are within a certain distance. Some population will love to be clumped together. If you consider, for instance, a group of sardines in the sea, you are going to notice that sardines, this fish, they like to clump together. Okay, there is a reason to that. So far, I told you about the population size, why the population size would fluctuate. I told you about the population density, about the population distribution. So now another aspect that we are going to take a look at is the age structure and the survivorship curve. Now, the age structure is very important because by knowing the age structure, we can basically say how many young individuals are in a population versus mid-age individual and versus elderly people. Okay, so this allows us to appreciate the population, how the population is likely to change in a year, in 10 years, in 50 years. Okay, and that age structure allows us to also tell how economy may be affected, because knowing how many individuals, at least an estimate of how many individuals are going to be in age of productivity in 10 years, 20 years, 30 years is going to allow us to make some predictions. That said, let's address the survivorship curves. Now, in the survivorship curve, you have actually three types of survivorship. You have survivorship type 1. Human and several mammals belong to that survivorship type of curve. At least we can classify them in that type of curve. So in that type 1, adults give care to the newborn so that the newborn are going to last a certain time before actually they are going to die. So basically, individuals in that group are going to live a certain time that is relatively long before they can naturally start dying. And then the next survivorship type, it's going to be type 2. Now, type 2, it's a relatively, in type 2, this is made up of species that actually can die anytime during their lifespan. They are not more likely to die when they are young than when they are old. At any age, they can die anytime. For instance, squirrels fall in that category of type of organism that can die about any time, okay, independently of the age, at least as far as we know. And also you have type 3. Type 3 actually is going to be made up of species that are going to be produced in large amount, and then the population is going to crash very sharply at a very early age, and only few individuals are going to remain and are going to be maintained. This is the type 3 survivorship curve. Now,